Good afternoon, everyone, and thank you for coming. This is Arijit Mukherjee. This is my co-presenter, Janet. We're going to talk about observability today, do-it-yourself observability. And one thing we can assure you that this talk is going to be as exciting and enjoyable as the beautiful spring weather we are enjoying in Krakow this week. So without much ado, let's begin. It sort of boggles my mind how much our world of software has changed in the last few years. To think about the fact that Amazon's EC2 came out of beta almost just 10 years ago. And same thing with Kubernetes and containers less than 5 years ago. And nowadays, if you're going to write any software, you're probably using one or more of these. So it's really like mind-boggling how quickly things have changed. And my favorite science fiction author, Arthur C. Clarke, any science fiction fans here? Yep. He predicted some of this. He predicted the arrival of the monoliths and also their disappearance after the fact. And really what's taken their place nowadays is microservices and containers, right? So this is what we're using to write our software with now, which is great because these things allow us to move much faster than we used to be able to do before, which is great. But there is also one problem with microservices and containers, which is that they're far more complex. Back in the day of the monolith, the interactions were much simpler. It was easier for us to make sense of them. I think if you try to debug a modern, complex microservice environment, it's a far harder task, which really means that observability becomes more and more important now, because without good observability, you cannot really fly the ship, so to speak. So back in the day of the monolith, our friend Ryan here, for him, the single pane of glass was really just a single pane of glass, right? But now, if you look at Pete, he's flying the plane, and he needs a cockpit full of instruments to sort of drive this successfully. And that's really the point. For us to be successful to fly in the clouds, so to speak, we need powerful tools, powerful observability to make that successful. But luckily for us, everybody realizes that. So if you look at all the major cloud providers, they do have observability support built in. They are producing a lot of telemetry that we can use and collect for our advantage. Same thing goes for the new frameworks, orchestrators like Kubernetes. Again, Kubernetes is built with observability support from the ground up, which is quite wonderful. And as a result of that, there is also a lot of different open source as well as commercial solutions out there that are exploiting that telemetry, that information that those software and clouds are providing, to benefit us. So any of you guys using some of these software out there? Yeah, I see quite a lot of hands. Any of you involved with your own company's monitoring or observability program? I see a few. So one of the things we notice is that this is starting to become a trend where companies will start on their observability journey. They're going to start using some of these tools, which is wonderful. God bless you all. And as you do that, initially you're going to see a lot of success because obviously this kind of brings capability, functionality that is sorely needed. So the other engineers are going to love you for it. You're going to see increased usage, more tools, more services are going to sort of start using it. And things are going to start off pretty great. But that, to me, is still sort of, in my mind, a prototype state. Because over time, though, the same users that were very excited are probably not going to be so excited anymore. They're going to ask for new and more challenging functionality. The service, which was perhaps very solid, very up, is probably going to start having some outages, some issues. This is just, the problem or pain of growing up. And so this talk is about how can you take DIY observability, which is to a mature state, because that is hard. We're going to talk from our experience, because sort of both Janet and I have been doing this for a while. So we're going to talk about what makes maturing DIY observability hard. What are some of the challenges that you should look at? Because it's not just about the tool. Monitoring and observability is a program. You need to look at it holistically. So what are some of the things that you should look at? And we're going to share some of our experiences as well as provide some advice. But a little bit of a warning, the advice we might provide may seem very obvious. So if you, at the end of the talk, you come to me and say, hey, Arijit, I went to your talk. All I saw was some stupid jokes, and I did not learn anything new. I apologize in advance. A little bit of a background. Both of us work in a company called SignalFx. SignalFx is a modern SaaS for monitoring modern cloud and application environments. It's a little bit of a different, it's a very technical, differentiated product. Among other things, it's very scalable, so we have a lot of very large enterprise customers. The other unique thing we have is a end-to-end streaming analytics pipeline, which for our users means that you get alerts in 2 to 3 seconds of an event happening, which in my mind is sort of revolutionary. So my co-speaker, Janet, she's been in the company for a while. She's one of our earlier engineers. She works on the user-facing application side of the product, so her footprint at this point is probably on most aspects of that. I've also been with the company from the beginning. I'm CTO now, and before this, I was at Facebook and helped build Facebook's monitoring system in their early days, so to speak. All right, so let's get started. High level, if there's one short message from this talk is that success is very painful, and success is going to lead to failure unless you remain ahead of the curve, so to speak. And it's actually a good problem in the sense that if there are more users using your service, if there's more services and data coming in your service, that's good, but they obviously will cause some problems. And one of the things you'll notice is as your company matures, as your users mature, they're going to demand more and more complex things out of the system, which is going to be part of the problem. Because in my mind, observability is not really just about letting you know that host X is having more than 90% CPU. That's important. But the role of this data is far more than that. It is to allow, in my opinion, data-driven decision-making within the organization. What does that mean? One of those could mean that capacity planning. You want to see how much infrastructure to deploy for this year's Christmas by looking at the trend from the last year. You might want to improve the product. Maybe you're doing A/B testing, and you're looking at the comparatively how do 2 different versions behave. A very similar thing can be done with performance. You have 2 different versions of software. How do they compare with each other, right? You may also want to do the stuff that happens after the alert, the incident management, the root cause analysis. All of this is going to be requiring your tools. So the kind of use cases, the things that you will want to do with this stack is going to keep getting more sophisticated, right? So let's start with the advice. The first one is you need to have all the pillars. Like if a building, if it misses one or more of the pillars, it sort of falls down. And that's also sort of true with observability. So the way we look at it, it really has 3 pillars that it stands on. They are metrics, traces, and logs, right? So in the beginning, you obviously want to get a very high-level view of what's going on in your environment, right? And you want to know if there's a problem. That's really the job of metrics. They don't give you the detail, but they give you excellent high-level view, and they're good for alerting. The next thing is traces. So especially in a microservice environment, if you see lots of microservices talking to each other in complex ways, it's hard to know where the problem might be. And if you have distributed traces, you'll be able to identify the location of where the problems are happening. So they're great for that. But you still don't know what the actual problem was. That's where logs come in. So if there's a specific error that's happening, if there's a specific exception that's happening, logs will tell you that. So our first piece of advice is you must look at it holistically. You must make sure you have all 3 of these included in your monitoring tool set. Because if you're going to miss some of them, that's not great. And if you think that you're going to be very successful missing one of these, for example, you just use logs, and that's not really going to work out very well in the long term, right? The next thing is, there's a famous saying, keep up with the Joneses, you must keep up with the others. Something like this is actually also very true in our case. What do I mean by that? Just look at the number of different software and services that are coming out every year, all the time. If I go to a reInvent conference this year, I almost guarantee you 10 or more new things are going to be announced in this just conference itself. And chances are your users are going to be using it, right? One of the things we see with microservices is a lot of other stuff is being deployed. So for example, SignalFx, we have about 40 different microservices. Of them, more than 20 are actually not our own code. It's running OSS, Kafka, Elasticsearch, what have you, cloud services. And that's really a trend. And the reason it's a problem is that these things are evolving, coming out all the time. So your system needs to keep up. When we first launched SignalFx, we initially launched a very, very capable metrics platform, highly scalable, all these analytics and so on. But that's not what the users wanted. We saw success after we added lots of integrations. By integrations, I mean built-in support for the stuff that the customer uses, for the users use, built-in support in the sense of making it easy for them to collect the data and observe what's going on. So that's really integrations. And your system must have strong integrations if you think your system needs to be successful in the long run. And again, the problem is there's new ones coming out all the time, and even the ones that are out, probably going to see new versions coming out all the time. So you need to keep up. Integrations is a program. It's not something that you can just do once and forget about it. You need to make sure that you dedicate engineers and resources to keeping yourself up to date. The next one is, again, a very famous thing, united we stand, divided we fall. In terms of data collection for telemetry, for monitoring, united we stand. We talk to a lot of customers, we talk to a lot of prospects, and I can tell you one thing, that those guys who we see have set up a unified data collection pipeline are typically the most sophisticated and the most successful when it comes to observability, whether they're using us, OSS, doesn't really matter. If they're doing it, chances are they are very sophisticated, they're being smart about it. The reason is requirements change. Things that you may need to do changes. The carpet weavers in Kashmir, they do something interesting. Every time they weave a carpet, they'll deliberately make a mistake in a stitch because they think that it is, for humans, it's not good to challenge divinity or God with perfection. And even though we may want to build our perfect monitoring system, you're not going to be able to do that. You need to be able to react. So the question is, how well are you able to adapt to different conditions? For example, if you find out at some point that, hey, you know what, your metrics backend is not working out very well and you want to try something else, how easy is it going to be? Is it going to require all your users and all your service teams to go and change some code and deploy and compile and all of that? That's painful. As opposed to, could you just turn a switch on somewhere and just key the data somewhere else? A pipeline allows you to do that. If your security team says, you know what, I want to anonymize some of this data because for various compliance purposes and whatnot, again, how much work is it going to be? Is it going to be a simple, they got a feed, so they just go and change some code somewhere? Or again, is it going to require all of your engineers to change all the code everywhere? If you're, a machine learning AI guy comes and says, I want to run some experiments, I want to run some data pipelines. Again, will it be easy for you to do that or hard? So as you can see, having a unified pipeline is very, very, very valuable. And one of the best pieces of advice we can give you is try to set something like this up. It is a gift that we'll keep on giving over and over again. The next advice, again, as I said, they're all very obvious. If it hurts to do something, just don't do it. And that's also true. Why is it relevant to us? Is that we are using small instances, microservices, containers, and so on, which means there are many of them. Right? And when you have many of them, you don't see a user go and say, you know what, I'm going to dashboard Docker container number ABC123 on a chart. They never do that. They will look at service health, which means they're looking at populations, not the individuals. Obviously, populations are larger. These are the things that people are going to dashboard and alert on. But because they are larger, the queries that you need to run to fetch the health of the population, for example, maybe P99 latency or average CPU or whatnot, they are more expensive. But these are the ones your users will want to do. And obviously, the problem is that these are going to cause performance problems in your system unless you do something about it. So the advice says, if it hurts, just don't do something. So a good advice we can give you is that you should try and pre-aggregate. So if there are common queries, things that are happening all the time, see if you can pre-compute them so that you just compute it once and use it over and over again. So for example, let's say if that P99 latency was important to you, why not pre-compute it in an ongoing basis and store it as its own data stream so that reads are very efficient, alerts are very efficient. This is something that I have seen being done pretty much everywhere that you run into scale. So if your company is growing, that's kind of very important, right? So Facebook does that, Dropbox does that, all kinds of companies will do that, where they'll do what we call service, across the service aggregations, right? Pre-aggregations. Another way of doing that is across time, right? So 1 second is, there are 3,600 seconds in 1 hour, which means that a 1 hour aggregate has almost that much, almost 4,000 times less data than a raw 1 second stream. So if you could aggregate across time, then you can also really, by a lot, reduce the amount of data that you have to process and make all your queries faster. That approach is actually what SignalFx uses internally. But pre-aggregation is, again, very useful and important. There's a saying that says slow and steady wins the race. In our line, we don't want slow. So I said slower, but steady wins the race. Because the kind of use cases that your users are going to want to run over time are so varied, it does not make sense anymore, in my opinion, to optimize for very small number of use cases at the cost of others. They say that every cloud has a silver lining. Another way to look at it is, every silver lining has a cloud, which means that if you're trying to make something better, what are you making worse? It is worth considering. So I'll give you a common example that I've shown here. When you have a large environment, let's say you have lots of Kubernetes clusters and whatnot, you may find that perhaps in a single Prometheus deployment or instance cannot keep up. There's just too much data. And a very common pattern we see is that, we will have one Prometheus for cluster 1, another for cluster 2, basically just divide and conquer. Makes a lot of sense. The silver lining here is you've solved the scale problem. You're able to handle the amount of data that you're getting in. But what clouds have we created? The problem is by fragmenting the Prometheuses, I'm also fragmenting the use cases. If I wanted to ask a very simple question, how many containers or pods am I running across my environment? You're not going to be able to answer that. That's not good, right? And obviously, once you fragment, you have the problems with fragmentation like hotspots, because they're not all going to run equally hot. And you're going to waste resources, perhaps have outages. So everything has a plus and a minus, and especially when you're trying to build a platform that needs to support many things from many users, keep that in mind. That's really the advice for this given example that I just mentioned. The approach that we use, and I think which paid us back over and over again a lot, actually, is to avoid hotspots. So in our case, we decided we're not going to fragment. Instead, we're going to try and store all the data in one large, scalable deployment of a service, where the data is actually evenly spread across all the nodes. So there is no preference for, service X going to node A or whatnot. It's actually randomly spread across the whole environment. The advantage, as you can imagine, is now we don't have hotspots, so all our queries sort of are, work reliably or similarly. And when bursts of usage happens, when somebody sends us a lot more data, it's like pouring water in a lake. The whole system goes up sort of slightly, allows us time to react, and it's really a good way to sort of go about it. The next one I'm going to talk about is metadata. If you don't think, you are going to sink. So what do I mean by that? Metadata is really king. If you think about it, your users are not going and entering host IP addresses and Docker container IDs in your charts and graphs. They are using metadata to express what they want to look at, right? So there's a saying which says, all of this, these infrastructure and applications, they're really like cattle, not like pets. We don't care about the individuals. We care about the populations. And the way they're going to look at your stuff is through metadata. So my question to you would be, how much metadata are you capturing in your observability system? It's kind of important. Is it only stuff that you're reporting while the data is being submitted? That may not be enough. For example, you may want to analyze performance of or cost or performance by instance types and whatnot. So when you're submitting data from a container or from an application, does it know what Amazon instance is running on or what Amazon instance type that is? Even if it knew it, is it really its business to know that and submit that? The answer is probably no, right? So the important thing is you need to be able to send metadata out of band, because you need a lot more metadata for all the different use cases you need. Another important thing I'll mention is that metadata is mutable. For example, a host may go into a maintenance state. You may want to see a chart where you only look at the ones that are in production, not in maintenance state. So your environment is alive, it's changing, it's mutating, and metadata is what allows you to sort of filter through them effectively, right? So the advice here is you must bring in as much metadata as you can. That the more, the better, right? There's no metadata I don't like, so to speak. And there's different ways to do that. You should have APIs so that your users can, by API calls, add and remove or change metadata. Then you should build synchronization syncs from these different systems. For example, CloudWatch syncs to bring in the cloud. Maybe you can have an asset database, and maybe you should sync from the asset database to your telemetry database, because again, that's how users will want to query that data. Metadata is very important. The last one that I'm going to talk about is analytics capability. Again, it's very obvious that the whole is greater than sum of the parts. But what do I mean by that? The name of the game nowadays is really about monitoring KPIs, key performance indicators, SLIs, service level indicators. If you ask your boss or your CEO what they care about, they're probably not going to ask you about the health of a host. They're going to ask about, is your service up? Is my business up, right? So if monitoring, if observability is aligned to what the business cares about, the better, because then it becomes far more effective. And so the name of the game now for either service owners or business owners, etc., is to be able to monitor these things. So that's number one. Even if you are able to monitor KPIs and SLIs, the question is, how sophisticated is your monitoring? For example, if you want to get alerted when the number of errors on your website goes up, let me ask you the question, what is the proper static threshold for that? I don't know. Because maybe if it's a consumer-facing website, the load is high during the day, it's low during the night, low during the weekend. Maybe you have a long-term trend that goes up. What is the right static threshold? The answer is there is none, right? And the problem is if you have subpar capabilities in how you're alerting on these things, then you're going to get alert noise, which is another huge, huge poisonous thing that you want to avoid. Alert noise is bad because your operators are going to not care about alerts when they are bona fide alerts, and they're just going to get drowned and inefficient, right? Let's say we solved the KPI problem, we solved the alert noise problem. Now I got an alert that maybe is important. Then the question is, how effectively, how easily am I able to go and troubleshoot the problem, right? That's also part of the observability stack's job. And again, that requires you to be able to do ad hoc analysis, right? Because you want to slice, dice, look in, drill down, go across. Like it's a workflow that nobody can predict. It's not something you can pre-can. And so your system better be able to support those kind of use cases, right? And all of that, in a way, is about analytics, right? Without analytics, none of those things that I talked about earlier are possible. In order to monitor your SLIs, for example, a percentile P99 of latency across a service, that's analytics. If you want to know whether the health of your overall microservice environment is healthy, it perhaps needs to look at many different data sets from many different services and combine a score. That's analytics, right? Similarly, if you want to look at sophisticated alerting, you will find that most of it ends up being dynamic thresholds, where you're not trying to call out a specific threshold like 50,000 errors per hour. Instead, you're saying, has the number gone up sharply? That's a valid way to look at it. You might say, well, I know it's a cyclical thing, so I'm going to look at the last 4 or 5 cycles to see if the current time is different from the past. That's a dynamic threshold. Or you may say, you know what, I have a population of hosts, and I only want to be alerted if one of them or 2 of them is acting weird compared to the rest. That's analytics. So the name of the game, again, is dynamic thresholds using smart data science and, of course, over time, AI, ML technology. So again, that's analytics capability. Similarly, for root cause analysis, you will need to be able to do these slices and dices, so which means that your queries must be fast, you must have a lot of metadata, and of course, analytics capability. So if you're sort of using your own DIY system or using some OSS, what should you do? The few things I would recommend you do are as follows. First of all, choose software, because there are a few out there that will let you do analytics, right? That's number one. But just the fact that it's capable of doing it is not enough. It needs to be used. What that means is you need to learn the capabilities that the platform supports, and you need to teach your audience how to use them. That's very important, because again, observability is a program. It's not just a tool, right? And you might find that there are certain capabilities perhaps that are missing, and if that's the case, try and go and build it. But invest in analytics. This will pay you back over and over again. So those are the things that I wanted to cover. I'm going to hand it over to my co-presenter, Janet, who's going to talk about a few more.
Thanks. So at this point, you've taken into consideration all the things Arjit has mentioned, all these challenges, and your system's up and running. People are starting to use it. Let's talk about keeping it running. Arjit has told me stories from when he was at Facebook where he'd seen teams spending maybe 50% of their time fighting operational issues instead of being able to focus on their actual work. And I'm sure you've seen even your own customers do unexpected things. Our own customers have done things like send us 4 megabyte payloads in a single batch. So this is 4 million data points at regular intervals. They've done other things like send metric names with timestamps in them or metadata values which flip very rapidly back and forth because they have an ephemeral environment. Things that have high cardinality and just are very resource intensive to process, just a lot of data. All of these lead up to what we describe as the noisy neighbor problem, where you have one misbehaving user who is affecting the usage for everybody else in the system. Because they're hogging all the resources, they starve out everyone else, and it essentially becomes an outage for everyone who can't use the system at all. Even internally, we've had an intern who misunderstood some instructions and ended up sending us data points every single millisecond instead of every second. And that ends up being tens of thousands of data points every single minute. Right? It has its costs ingesting all of this. So there's a few things you can do to address this. One of them is have tokens per user. So you assign a token, and you can sort of track them as they're using your system. You can set quotas and limits on each user, and then throttle them when they start to exceed their limits. Another thing you can do is have a relief queue, so a way to partition out users who are causing high load on the system. So basically running them in parallel instead of everybody coming in through the same pipeline. Even more broadly, if you have users you know who are going to be using the system quite heavily, you could have a totally separate environment for them, a separate instance, and even partition your users even more. So once they start sending data, you're going to start seeing it accumulate, and there's going to be cruft and old stuff that nobody is going to touch anymore, and it's just lying around taking up space. One of the most common questions we get from our customers is, can you tell me things that nobody in my organization has viewed or edited recently, because they just don't need it anymore. And having it lying around makes searching for what they do want very difficult and slow, right? Having to wait and sift through everything. And on your side, you're paying for the storage costs of this. So in a way, you're paying for a bad user experience when you don't clean up data and resources that are not used. To give a concrete example, I had worked on a Mesos integration where people could send in metrics from their Mesos cluster. But while I was working on it in our lab environment, I wasn't quite sure what I'd want to name my metrics, my metadata. So I tried different things out. I eventually figured out what I wanted, but when I was done, I had ended up creating a lot of clutter in our system, and people who were looking for Mesos information got confused. What is the real data? What is it that I actually want? Because there's all this old stuff. So one way you might want to address this is to have a retention policy on old data or resources, things that haven't been touched. Maybe you can expire them, mark them for deletion, and eventually get rid of them. Of course, we do want to encourage our users to actually use the system. So usability with any system is going to be very important. Your user satisfaction is going to be a key factor in how successful your system is going to be. As the content within it continues to grow, how do we have everyone continue to get value out of what they're seeing? What we typically see within an organization is that a few people become experts. Like they'll know the ins and outs of the system. They'll be able to find everything very quickly, create everything. They really know what they're doing. And then everybody else, which is going to be the majority of the users, they don't know as well. They only log in maybe if they get sent a link or a page and need to check out an alert. Right, so how do we address the user experience for these casual users? How do we help them find what they want? We want them to be able to get value right out of the box. Like as soon as they log in, how can they find something that's relevant into them? And for this, we can rely on those expert users that I had mentioned, these people who know what to do. So let's say you have a Cassandra cluster that you monitor. Why not rely on your Cassandra experts to curate all the dashboards, all the alerts in one place for people who want to know about Cassandra? They can just go there and look at it. Or even maybe create templates that they can make for those other users who want to build more Cassandra information or build on top of what's already there. And when you start to get more data and more content, you're going to start seeing an increased range in quality. There's because you have the casual and expert users, there's going to be a little variance in what you see. So how do we make this standardized, or how do we make it useful for everyone still? How many folks here are part of an on-call rotation? Okay, some. And then how many of you have been woken up in the middle of the night from a page? Yeah, so you'll probably be able to relate, right? I've been woken up at 3 a.m. I get paged about some service I don't know as well. Thankfully, the service owner had put a runbook and a dashboard link into the alert, so I could just go there, see what I need to do, quickly resolve the issue. Because at this point, resolving the issue is important to me because I want to go back to sleep, right? And I don't want to wake up other people to help me figure what's going on. So having standards, training and educating your users about what's going to be valuable to people, because this is a monitoring system. That's what you're using it for, to be able to resolve your issues quickly. That's going to be very important. Even for data collection, so like sending in your metrics, your metadata, having naming conventions will create a shared understanding with everyone, and so that they can make sense out of what is it that they see. Now let's talk a little bit about security, keeping your system safe and sound. We want to prevent accidental, and hopefully this won't happen, but even just intentionally destructive behavior. So at the beginning, right, regulating who's being able to log in. If you have integration with something like LDAP or Active Directory, single sign-on, that's going to be very convenient for regulating that. Once users are within the system, having access control to the resources, so like maybe role-based access control at a very basic level. You could have like admin and non-admin users, and then read-write permissions to control what's happening with the individual resources. For example, we've had a sales engineer internally message on Slack, hey, somebody keeps changing the config on my dashboards, and it's messing up my demos. If in an even worse situation, your data or your information may actually be missing if someone accidentally deleted it, right? So having a way to export and back up your information, and then a way to easily recover it, import it back in, that's going to be a lifesaver for someone, right? I guess this seems obvious, but it's something you just have to remind yourself that this is something to think about. And then as your company grows, one of the things that may become more relevant or requirements that are going to come up are having restrictions surrounding data security. So maybe you have more sensitive information related to your company's business that you don't want everyone in the company to see. There will probably be requirements on having this more restricted, hiding it completely from users. And you may also need to have audit logs, being able to keep track of who did what, when, and where, and how. Cool, so at this point now, people have been using the system longer. They're starting to have more advanced use cases. They're going to want to have more flexibility in what they can do to be able to use the system more efficiently, more consistently, in a streamlined fashion. A big trend we see right now is doing everything as code. Infrastructure as code, monitoring as code, even charts as code. A lot of our large customers, including Yelp, have been pushing us to support things like Terraform, which we can do and empower our expert users by having an API, so they can do everything programmatically, consistently, reproducibly. So to sum up what we've been talking about, basically, observability is a program. It's not just a tool you put together. You have to kind of nurture and feed it and really help it grow. Right? As your environments become more sophisticated, more monoliths, we have microservices, service meshes. Observability is very critical, right? You want to know exactly what's going on in every part of your system at all times. DIY is very popular. There's so much open source software out there, right? It's very easy to put something together. But you want to make sure you do this in an organized fashion. It's a difficult problem for the reasons that we've gone through today. Your users will have different use cases just based on their own roles within your company. They'll have many different types of things they want to do. Even the systems you are monitoring are evolving and changing all the time. Right? Cloud is popular right now. Who knows what will happen in the next 5 or 10 years. At the same time, as your business grows, security and compliance become very relevant, very important for your business needs. So tooling isn't necessarily going to cover all of these requirements. You're going to probably have to have human processes as well to adapt to all these changes. So again, invest in your program. Avoid getting in this situation where you're just fighting user issues, because user frustration is going to affect how much faith they have in your system. How willing are they to adopt it and continue it? And ultimately, that affects the long-term success of your observability system. So if you found any of this interesting, you have questions, you want to chat with us, we'd love to talk to you. We do have a booth in the lobby, and we just opened a new office right here in Krakow. There's an office opening party this Friday, tomorrow, at 7 p.m., and we'd love to see you there. If you'd like to have an invitation, please stop by the booth after this talk. Thanks. Oh, and one more thing. So Arjit will be speaking more at the office opening party, sharing insights on effective strategies for monitoring Docker and Kubernetes.
Cool.
So
Any
I guess
questions?
we'll check if the Slido has questions.
Yep.
Okay. You want to-
First question, doesn't the more metadata, the better idea cause unwanted noise? Metadata by itself will not cause unwanted noise, because noise happens when you create bad alerts, right? Having more metadata actually allows you to reduce noise, because you can probably slice and dice the data the way you need to. So I kind of don't agree with the fact that metadata will increase noise. It actually helps you potentially decrease noise. And as I mentioned, it allows you to look at data many different ways, right? So your finance guy can look at data from a cost perspective. Your capacity planning could look at data from whatever, like a cloud perspective. You can look at data from an operational state perspective. So I think by having different ways, different lenses to look at the same thing gives people what they want, without having to try to do maybe hacky things, which I think would increase noise. So in case the problem wasn't observable, do you add instrumentation at 3 a.m.? That's a great question. Yes, so we should keep on adding instrumentation. If you're up to it at 3 a.m., sure, go ahead. But in general, though, I think part of the incident review process, something that actually Leonie talked about yesterday, is that you need to figure out, like, what did we do right? What is missing? If I'm not able to have enough information to troubleshoot the problem, like your changes to your observability, like what needs to happen, it should be part of the incident review process, because it is very important. It's the only way you'll be able to get better signals next time, because problems are not going to end. They're going to keep on happening, right? So yes, I think part of the incident review process is not just, I'm going to change this configuration here, or make this deployment there. It should also be, what am I changing from the instrumentation, the observability, the alerts, dashboards perspective to make things better next time. Last question is, how is the observability program perceived around the company? Is it cool? Great question again. Yes, because I think in general, this is a very interesting and effective thing, right? So in the sense that this talks about lots of data, it's about analytics, who doesn't like this kind of stuff? And what it's really doing is allowing customers to set up, or your users, not customers, your users to set up effective ways to monitor themselves, to operate themselves. So yes, it is actually not only just a utility. I think the kind of work is very fascinating. For some of the reasons we described, it's a very dynamic field, so to speak. One of the things I'll share with you is that what we find is that over time, when a company sort of starts growing and this becomes more and more critical, what we see is a pattern where the observability becomes like a function. So, so you'll actually have a full team who are going to produce best practices, who are not really observing anything by themselves. They're just providing you with the tools that the rest of your company are going to use. So then they become like the focal point for a lot of requests and so on. So yes, I mean, I've been in similar teams myself, obviously, and we see this a lot in a lot of the sort of the larger companies, the more successful companies as they sort of grow. This is a natural evolution we see. Obviously, it's not for everybody. For the kind of guys who like data complexity, metadata analytics. This is actually quite a fascinating field from an engineering point of view. So yes, it is definitely cool. I would say that. Any other questions? For those of you who asked those questions, there's free T-shirts. So after you're done, please come on down, and we shall hand you out T-shirts. And if they don't fit your size, just come to the booth. We'll fix it for you. All right. Thank you very much. Thanks for coming, and it was our pleasure to talk here.